Jehehe. Yeah, let me see if I got the title right. I messed. I think I messed. So, okay, we got it now. Oh, didn't change the image. It didn't change the image. This is like a lot. This is from the other one. Yeah. I messed this thing. Okay. Anyway, this image will appear later. It's not important. Well, it is important, but now we're here. Yeah. Exercise exercise 5.12. Write fibs from continually at once in terms of unfold. There's a little note. Using unfold to define continually and once means we don't get sharing as in the recursive definition, but once list. The recursive definition consumes constant memory, even if we keep reference to it while traversing it, while the unfold-based implementation does not. Reserving sharing isn't something we usually rely on when programming with lazy list, since it's extremely delicate and not tracked by the types. For instance, sharing is destroyed when calling even xmap. Okay, you need to understand this paragraph. You need to trace the execution of these functions, I suppose, and see that like data sharing has been lost. I don't know. Which one should we take? Hopefully, once is simple. Where is it? Oh, I will answer this email later. We can close it. We can close this. It can be here. Oh, 10% energy. Valve. Okay. Valve once using port. Replace list. Type int. Now, what can we use? We can use continually. It's continually. Here this. So something's. I think it's not working for this. Okay, now we have the auto-completion. And unfold expects an state and a function takes and this state and transform it. So let's take a look at unfold state match. Okay, in state, so we apply if that state if it results in none, then we return empty. What can we give this? Dogs went crazy, man. Can we pass in state for one? And we pass an int so int and a function that produce some uh, tuple. Let's put it like that. Using default take type list. Now see if it's like it, if it like it, if it like it, if it likes it, and apparently it worked. Uh, I think while greater than 10, this should be an empty list. Okay, takes 5. Okay, we wrote once using unfold in this way. Are we live? Yes, minutes. Um, if you need like an explanation to this, it expects a state, and we are of type S. We are given anything S, any state. For us, it is number one, which is of type int, and it expects a function. We are not going to use the value, so we are putting this underscore. But it is a state, so it is Scala is inferring an int, and over here we need a value of type A, type int again. Since we will cons a lots of ones, we're passing that some. Then the state, which is one, like we are not using at all. Ones is already. It's the last one. We're going from the easiest to more complex. Now let's write continually. Oh yeah, ready to see me? Yes. Continually using default type variable value type A. Release, A. And if you ask me, it's like more easy, more simpler. We just count something continually and recurse over this function, like you are spinning. But now with the unfold is like more like you are generating values, like you are imagining like a bubble doing like this effect. Okay, unfold. Oh my, sometimes this can work, sometimes it doesn't. We need a state and we need a function. What does this is like once, but with the given value a. So so we are passing a, and we are passing some I don't care and some a. A. Now let's hope for this thing to work continually. Yes, continually using a code. Uh, 500 Now let's use more smaller numbers. Take take 3, list, take 5, take 5, and okay, 1, 2, 3, 4, 5, and take while this thing is greater than 10, 100 should be empty, and we have our empty list. Okay, 2 down, 2 more to go. 16 minutes. So where is this person that always comes, always shows up in these videos and then leave? Perhaps it's like some, like some programs that are crawling all over the web, gathering information. I'm not sure. Maybe it's very late at night. 10%. Um, Once continually. Now let's go with from. Here's this. Things are becoming more like interesting from using fold. If you want to test this, you want more confidence, I show how to follow the Oracle strategy and some videos at the beginning of this series using Scala check. You can do that. Then. I'm using a board. It's from preceding something, yes, an int. And what's it's returning my lazy list of type int. And what what this thing does is to add one to the next call in the next call. We need a state, we need a function. I'm sorry, can't help to feel sorry for the people in the future that won't be able to program like this. But perhaps this traditional programming will become like playing chess, millennia activity that now belongs to the leisure time. And okay, we state will be n. Now we are in trouble now. Now we have some value because we are going to use it. Some some value and value plus one. Please works. I'm going to explain this if this works. Okay. Left list from using fault. Let's use 25. And see, take 5 to list. Please work. 1, 2, 3, 4, 5. Yeah. Okay, now it's time to so you know it, right? If you're here to learn something, what is please try this exercise. It doesn't matter. You don't have to be live coding. It doesn't matter if you tinker a lot. If it takes you 3 hours, it's okay. But if you already tried and you're here to gather some idea, well, thank you. And okay, we need to start from a value n. Where is n? And we need in this version we are recursing calling from having one at any given recursive call. So in our unfold version, we need a state. Here it is, and that state it gets used by the function that you are also passing. If it's none, then you return empty. If it's if the thing works, if it is the dogs went crazy again. If the things work, you construct. If you have some value and some state prime modified state, then you const the value, and call unfold with the modified state. So this is the value. This is the function. Look at this. Sum the value, the first value that you are going to construct. Then you need a state prime to be used again by the default. You're adding one to that one. So at minute 24, the dogs went crazy. Fibs, Fibonacci's. This will be. This is a good one. Where is Fibonacci? Here it is. We have constructed fibs in a way that uses an internal pivot end that it gives you the end Fibonacci number, and then you start constructing the Fibonacci's. This function is also inside. Perhaps we can extract this function to be used by the involved version 2. It will be something like this. But we don't want to repeat this code, so perhaps we are going to extract this code because this was this was we put this thing outside this companion object because it's not even an utility function. It's more related to a mathematical library. Well, we are going to, if perhaps if you have experience in object-oriented design, you will say, we are losing encapsulation over here. Uh, Perhaps, but this is taking me too long. Now we're going there. You notice. Let's see if this thing works. Where's Fibonacci? Okay, because we're going to use these two with fibs because the box requires fibs to use involved. We need this pattern. Oh, yeah. Where is it? Okay, over here. It could be a little bit different. F fibs using fold. It returns my lazy list of type int, and oh, I need to use unfold. Unfold. This is a good one. With a state, we need a function. Uh, let's use what can be used as a state. I think we can use. Let's but let's focus on the function first. We need a state. Let's take a look at from n, and then we have a value. I think there's something if uh, if you want to understand some like kind of disconnected stuff. If you want to connect this value is this state, and look at this. Hopefully it works. Let's use Jerry. Okay, so you can see that. So you hopefully now you see that this state is this state in the function. Now we need to do something similar with I think this Fibonacci's it belongs here. You see? Let's see if this thing still works. Yes, right here. Now we can write the single port. And we will call Fibonacci's. Fibonacci's. We will have another Fibonacci's. Def Fibonacci's. Fibonacci's 0. And now Fibonacci's 0. Sorry. Fibonacci's. Fibonacci's. Start And my lazy list. Like sometimes this thing works, sometimes it doesn't. Well, lazy list like int equals. Now we can call on for with the start uh, on the functions start uh, and call fibo start and some fibo start and start is one. So you have both version of fibs. Let's see if it works. Fibs using on default. Take 7 to list, and we got it. 0, 0, 1, 1, 1, 1, 2, 2, 3, 3, 5, 5, 8, 8. We uh, we we did it. Perhaps you want uh, to see something like without this auxiliary function, Fibonacci's, and call directly on form of without this. Uh, can we do that? Can we do that? It will become 0. This remains the same. This state is this state. In order to let's take now 6. 0, 1, 1, 2, 3, 5. So yeah, now let's take 8. Yes, let's go back to 7. And you have fibs using unfold without the auxiliary function Fibonacci's. So yeah, we will have this still outside, so Fibonacci's using unfold can use it. And you see the relation. This is the state. This state is arriving. Fibo start, Fibo of 0, and start 1. For yeah, 40 minutes. I really like it. I'll see you any other day. I'm going to play the guitar, I suppose. But yeah, we did some code today, even in the night, which is great. These are the famous last words. If you want to leave, stop the video. But let us start for 1 minute. What can we say in 1 minute? Yeah, it's become challenging. Perhaps this week I will tackle some of the exercises. I don't know. I don't know. I'm not sure. So if we end doing some other Scala functional programming book in the Scala, well, see you over here. Good night. Bye.